When we looked at factoring trinomials with a leading coefficient of 1, we introduced a specific tactic that works in that scenario. Now we want to introduce a new factoring method called factoring the difference of squares, which again only works in a very specific case. The pattern that we need to pick up on here is that we need some value squared minus a second value squared. So something of the form a squared minus b squared. If we have an expression like that, a polynomial expression like that, it will always factor into the form a plus b times a minus b. In order to apply this method then, we need to first recognize or verify that the expression we have fits this pattern. In part A, we have 9x squared minus 1. 9 is a perfect square. X squared gives us x as a perfect square. So we can rewrite this first term as 3x, that quantity squared. And then 1 is also a perfect square because we can rewrite this as 1 squared. That means we have this pattern where a is equal to 3x, b is equal to 1, meaning our factored expression in this case would be 3x plus 1 times 3x, and it's always going to be minus in that second factor, minus 1. Since we can recognize that pattern, that we have the difference of two perfect squares, we can use this specific factoring method called difference of squares. And we can check that result by taking the first factor in our first binomial times that second binomial. And then we can take our second factor from that first binomial times the second binomial, meaning we can expand this out, which will give us 9x squared minus 3x. Then distributing the 1 through will give us 3x minus 1. And what we'll see every time in these scenarios when we expand something out in this form, that those two middle terms will cancel out, and we'll be left with 9x squared in this case, minus 1, which was that original starting expression. So again, what we need to verify is that we can rewrite each term as some quantity squared. And if we can do that, then we'll be able to write this factored expression as a plus b, a minus b.